Welcome to Module 3, Graph Analysis, Clustering and Transitivity. In the video on connected components, we talked a little bit about clustering, but not technically about the correct form of clustering. Because in real-life networks, we quite often have the case that nodes are clustered around each other. So in social networks, this means that friends of friends are also likely to be your friends. So we have a triadic cluster where you have a triangle of connections. And in graphs, this is exactly what we see quite often, that we have those triangular connections rather than open triplets, which looks more like a chain. So on the left, we have this connection of you're friends with a person whose friend is also quite likely your friend, rather than a friend of yours has a friend that you're not friends with. And that is something we really see in real life as well, that we hang out with people who are also friends with other friends of us. If you show up at a party of a friend, you're most likely to meet other friends of yours there, because they are also friends with the host. It's quite uncommon to go to a party and know no one except the host. Sure, that happens, but it is extremely unlikely, because in real life people cluster. And if we look at this transitivity aspect here, the transitivity measures the likelihood that two nodes connected to a common neighbor are also directly connected. So we look here if one friend to the host and another friend to the host, are those two friends also friends, which is relatively likely if we have clustering. And in order to do so, we quite often have that directed graph are interpreted as undirected just for the sake of calculating transitivity here. And we have to differ between two different kinds of transitivity here. On one hand, we have the local transitivity. We calculate the transitivity for each specific node, and we have global transitivity aspect where we look at the average transitivity over all nodes. For the local transitivity here, the also not large component connected, but also LCC, the local clustering coefficient here, is we measure how close a node's neighbor is to form another complete clique. So we have the number of pairs of neighbors here represented in T that are connected, and K is the degree of node I. And so we can calculate the local clustering coefficient. And intuitively, it gives the average probability that a pair of I's friends are also friends with each other. So how many of those triangulars do we have in a simplistic expression here, but more mathematically thinking on probability? So if we look at this graph here, you see that node A to the far left has two neighbors, B and C. And B is connected to C, and because we're undirected, vice versa. So the number of pairs of neighbors of A is 2, and the local transitivity is 1, because of those two neighbors that A has, both of them are friends with each other. If we look at node B on the top here, it has 3 neighbors, but only one of them is also connected to the other two. So we have a transitivity of 2/3, because A and D are not neighbors. So a third of them is not connected. And so on. And if you look at the right, you have the node E hanging out there with one specific neighbor that cannot calculate local transitivity, because the neighbor D cannot be friends mathematically and technically speaking to any other neighbor of E, because E just has this one single friend. And so instead of having an infinite or zero transitivity, the transitivity here is not defined. On a global transitivity, we look at an aggregate measure across the entire network. And if you look into a standard graph theory textbook, the average of local clustering coefficients is the global clustering. So we average over all local clusters coefficients that we have and get the global clustering coefficient. If you pick a network, calculate it through by hand, you have a result And then you want to check that with a software package like R or Mathematica or MATLAB. And what you will see is that you get a different result. This is not because, well, the math was difficult, but it's not that the math is wrong. The case is, be careful, global transitivity measurements have, especially in software packages, a different calculation. There are different algorithms. So whenever you state global transitivity measures, make sure to also state which kind of global transitivity you're talking about, so people are not getting confused. So this is really, really important. If you use a specific measure to describe your graph, state it and make sure why you're using that specific measure and if it makes sense and why it makes sense for the specific problem on hand.